I just leave it up here and I'm gonna come back for it.
Thank you.
Seven?
Yes. Mr. Jameson, will you grab a seat with your folder, please?
That's what I said, man, awkward.
That was this tutor session?
When you want me to prime factorize 150, right?
Yeah.
Let me, do like 3.
Yes, you can do the trick.
Wait, I used the same folder from
Red folder.
geometry? Oh.
You should have a red folder.
I think I came in late that day.
Okay. Then grab your geometry folder, that's fine. We'll get that situated next week when Foster's in final. You wanna sit over here, here, or here?
You're supposed to me. Let's go mad.
You're sit next to Steve.
Let's go mad.
Hey, you're getting a private education. Proud of that. Okay. So, what are prime factors?
Prime numbers.
Okay, and those are what? Give me an example of a prime number. 2,
2, 3,
3, 5, 7. What do they all have in common? That's interesting.
They
Not always.
If they're only multiples of 1 in itself.
Their only factors are 1 in itself. Very good. Is the number 1 a prime number? No, it's the tricky one. 1 is not a prime number. So what is one prime number that you know goes in the 150? 3. So you want me to do 3 times 50? 3 times 15.
It's 3 times. No, 10 times 15.
Okay, 10 times 15 or 3 times 50. Because 5 times 3 is
Okay.
15 extra 0. So let's do 5 or 10 and 15 like you said. Now, are either of those prime numbers? No, so I don't circle them, I have to factor them further. Well, what are the factors of 10?
5, 2,
Yes.
And they're both prime, so I circle them. What are the factors of 15?
15 is 3, 5.
And they are both prime, so I... Now I need to summarize, and I go with what? What number first?
2, and then 3, and then 5 squared.
5 squared, very good, because I have how many 5s?
2.
Awesome. Okay, second part of today's Do Now is actually leading into what we're going to talk about today, which is translating word sentences into expressions and vice versa. Then we're going to go dig deeper and further and make our brains sweat and do big word problems.
Come on, no.
So, we made up a list of words yesterday that associate with these symbols. So we have plus, minus, times, divide, and then common words that we sometimes use with those. Twice. What operation is twice? Multiplication. So I'm going to write that underneath it. Multiply by 2. What is the sum? What is that kind of operation? I'm going to add. What am I going to add together? A number. So I'm going to add a number.
Number 9.
And the number 9. So how am I going to write this in an expression?
Twice.
2 times.
N.
Okay, n
N plus 9.
plus 9. Now do I have to I want to multiply 2 times 9 as well. And if I just write 2 times n plus 9, I'm not going to have the whole answer. I know. Yeah. Start to fold in. So this is leading in today. And what we're going to do today is I'm going to read aloud some sentences, and you're going to write down the sentence and then translate it. And I'm going to write the sentence, and you're going to translate it. Any questions? Good? Okay. I'll leave this up here so that you can copy this down. And I'm going to give you out the packet of today's work. So again, today is Thursday, February 7th. That's today's due now. Make sure you have it copied before I get rid of it.
Say January.
February. Should I say January? My bad. Big period. I'm going to move this over here just so we can all still see it.
Oh, we gotta write
Okay, so you have number 1 already written out for you. To the right where I drew the arrow, please translate the sum of 8 and y into an expression like we did up here.
But we don't have to solve it, right?
No, there's no solving, it's
Y
just
plus
translating.
8.
What?
Y plus 8.
I'll put 8 with y.
Does it matter? Why? Why doesn't it matter?
Because it's addition.
And addition is what?
Just adding.
Okay, addition is commutative. What does it mean to commute?
Combine.
Commute. Put together. Put together. Do you commute every day?
Yeah,
What do you do when you commute?
goes both ways.
You go both ways. What do you commute? When you talk, that's communicate, okay? But how do you get to school every day?
Well,
You travel. So this y can travel over here, and this 8 can travel over here. Will it ever change the answer?
no.
8 plus y and y plus 8 are the same thing. But what if I did this? Is that going to give me the same answer every time?
No.
No. Addition is commutative, but subtraction is not. Because what's 7 minus 8? Okay, what's 8 minus 7? Big difference, right? What's 8 plus 7? What's 7 plus 8?
Same thing.
Same thing. Doesn't matter what order it is. Okay? The order doesn't matter. So the answer to number 1 was either 8 plus y or y plus 8. So whichever way you want. Okay, the next 2 I'm going to read, so I want you to listen. And as I speak, I want you to write down the sentence I'm saying, okay? 4 less than x. So number 2, 4 less than x.
I just write.
Write the words 4 less than x. And then after you write the words, just like I wrote here, you're going to translate it. And then translate that to an expression. Alright, I'm going to write the sentence up here now that you all have gotten it down. 4 less than x. Now, what operation are we using? Subtraction. Less than, keyword, subtraction. Got that off our keyword list. So I'm going to do subtraction. Now, with the word less than, 4 minus x,
I said x minus 4.
why did you say x minus 4?
Because taking away 4 from x and saying 4 less than means whatever x is. Okay.
Very good, Steve, but that's exactly the point. Think about it. Our class, we have 7 less than our class. Make sense? I'm going to have our whole class, I'm going to take away 7. I'm not going to have negative of us, I'm still going to have a positive of us. So when you have the word less than, whatever is in the front goes to the end. So it's going to be x minus 4. Very good, Steve. Okay? Alright, this is another listening one. X multiplied by 13. X multiplied by 13. Now that one kind of gave it away, what operation we're using. Multiplication.
So
Now let's think again about number 1. You said that it doesn't matter. Excuse me. Addition is commutative, and so is multiplication. Doesn't matter the order. Doesn't matter the order at all. So the sentence was x multiplied by 13. Let's get your folder. Actually, just take a packet and read your folder right now. So I could write this either 13x or 13 parenthesis x or 13 dot x or x first. Do you want to put x first? Go for it. Number
I
4.
can't do x times 13.
You could. If you want to change the order of x and 13, you can do that. But those are just some options. Alright, this one I'm going to write down, so you're going to read it. So if you want to think about that word, look for it. Say right here.
Quotient's division, right?
Very good. Quotient is division. What other words do we think of when we think of division? Divide, divisor, sharing, dividend,
Yeah, that was the word I was trying to remember. Ratio.
ratio, and this is the big one, fractions. Fractions are very much division. Which is why, what was that weird word we talked about yesterday in the real number system that we call Q? The rationals. Rationals are fractions and division. They're called Q's because of quotients. Fractions and division, quotients, all the same thing.
So it's x divided by 3.
Okay, so the quotient of x and 3 would be x, you can write it like this, or write it like this. Divided by 3, good job. There you go. Alright, number 5 is a listening problem. The difference of 5 and y. The difference of 5 and y. The difference of 5 and y. Okay, Aaron, what does difference mean? What operation we're gonna do? Aaron? Subtraction, very good. Put a minus sign right there. Now, with number 2, what happened with number 2? Okay, it wouldn't work if you were to switch it, but the key word in number 2 was the word less than. 4 less than x. Is that the same kind of situation we have with difference? No. So with the word difference, we just follow the numbers. So it would be 5 minus 1. Okay, number 6. Tyreek, ratio, what operation is that? Division.
I think it's 9
9 x over 2. Alright, what does the word more than mean? Add. So I want to do 9 plus x over 2. Very good. Alright, this one's verbal. Ready? 9 less than the total of a number and 2. 9 less than the total of a number and 2.
plus x. Okay, number 2.
And 2. Alright, I'm not gonna write this one on the board. I just want to hear what you guys have to say. So,
I was gonna say,
what kind of operations were you using in this?
Addition and subtraction.
Addition and subtraction. Very good, because what's the key word for addition? Total.
Oh,
And then 9 less than is the subtraction. So how am I gonna write it?
2 plus n minus 9.
Right.
I'll put it for
2 plus n
Minus 9.
No, McKay's teaching.
minus 9.
Yeah, that's fine, she's good.
And I'm gonna keep it as a parentheses. Why?
Do it first.
Okay, do it first. Only because, what if I have some other way to the order? The way it's read, ready? 9 less than the total of
Yeah.
the number and 2. I don't want that 9 to be thought as a positive 9, it's really minus 9. So I don't want to switch up the order. So that order is important from the way that you read it. Okay, so we are going to skip number 8 and move on. Before we do the lengthy problems, I want you to take a look at ratio and proportion. Okay. So, Tyreek, what does ratio mean again? Division. So beside it says ratio and proportion, you're going to start looking at that. And start working on that, and then we're going to pick up from there and move on to the lengthy word problems.
I don't say that.
Stop, please. I'll be right back. Yes, it is.
Okay, 6 and 30. 5 and 20. 5 is 50. Should we do 4 and 10? Should we do 5 and 20?
Son, no,
Add it.
you dumb, Monica. You dumb, Monica. No, you're really dumb, Monica. If she could do 4 math problems in 10 minutes, in 20 minutes, she could do 8. Oh, that's not so. Wait, how you felt?
What are we supposed to do, this or this? The one with the kids?
Yo, that confused me. No, I'm just thinking it's really not a division problem.
I'm just trying to.
No, I'm right.
Scrap paper.
Which one?
Scrap paper.
It's scrap paper? And you guys need scrap paper? Take some of this.
Mr. Graham? Get back. What? Does he have to add these?
She
That's
has
right now.
like you have to. You gave me 10
So
minutes.
I
So in 20 minutes.
Right, so you need to do this.
8.
Oh, I got it again.
What do you have to do first?
What's that?
You have to sum up the numbers.
First is, well, that's the first step. You should have one first.
I was gonna say scrap paper.
You know what, it's older, way bigger.
You're on the wrong side.
We're on the wrong side?
Ratio of the
But you said
Oh,
this
you're
was the
doing that.
right side.
Oh, my bad.
Because I said, so Tyree, what does ratio mean?
So you should be the ones to step in there.
Yeah, but.
So, yeah,
No, you didn't. You were listening the whole time.
it's okay, that's not, it's a secret.
Okay,
And I was doing this.
let's talk about one. Chang can solve 4 math problems in 10 minutes. How long will it take him to solve 30 problems? This is a proportion. How am I going to set this up? Yes. Alright, so our friend Chang can solve 4 math problems in 10 minutes. Okay? How many problems, I'm sorry, how long will it take? So how many minutes to solve 30 problems? How will I solve this? What's one way we want to try?
Who knows 4 every 10 minutes? Multiply.
Okay, so if I have 4 problems in 10 minutes, if I have 30 problems, how many minutes will it take? It's gonna obviously be more than
Yeah.
10 minutes. Well, if I added 4 more problems, I'm gonna be 8 minutes, or 8 problems.
20 minutes, yeah.
Okay, so let's you can think about it like that, but is there an easier way to do it?
Yeah.
There must be the way we're talking. Okay, Mr. Linden, do you have an idea that you want to try?
For this?
Yeah.
Well, what I would do is, you see where it says a question mark for minutes? I would put an X there. See? Grandma's the collector. How does that help? Well, how does it help? What can you do?
Oh.
What do I want to find here?
Multiply.
You call
Cross multiply? You want me to cross multiply?
No.
Think so.
No?
Yeah.
Do you want me to cross multiply, or do you want me to straight across?
Straight across.
Do you want to try both methods to see which one works? Okay,
I don't think come on, we didn't do it.
let's do it both ways. Let's go straight across. What's 4 times 30?
1,200.
120.
Oh.
What do you do? 4 times 3, add 0. And then we have the number of minutes.
That's wrong.
What's 120 divided by 10? 12 over x. So, does that look right?
Like I said, the way I said it.
I think that looks right.
Oh no, I want to know what you have to think.
Whoa. Slow down. Hold on. We are talking again.
Okay, so
I
now
want
you
to
guys.
hear
This
what
works.
you have
This
to
works or
think.
not? I
Does this
don't know.
work or not?
What do you think? Is this
I want to
working?
hear what you have to think. Well, let's try cross multiplying.
X.
So I have 4x equals 300. How do I get that x across away? Or alone?
Divide.
We'll divide 300 and 4.
Okay, but what's 30 divided by 4? What's it close to?
26.
It's close to 26, but really 28. It's close to 28.
So 228, correct.
What's 28 divided by
280.
7. It's going to be close to something with a 7 in it. Now, is it 7 or 7D?
70.
7D. Okay, is it going to be more than 70 or less than 70? Because we said 280. It's going to be more than 70. It's not quite much more. So at this point, if you don't know, I would take out your calculator, and it's 75.
So like I was saying,
So it's going to take him 75 minutes. 75 minutes to do 30 problems. So we tried one way, it did not work. Tried another way, it worked. Trial and error, my friends. Okay, so we're going to put this aside just for a minute, and we're going to take a look at those lengthy word problems on the backs of that packet. Okay?
Just speak for life.
All right, number 1. Sadiq, will you read nice and loud the problem number 1 for us?
Sure. 555 mile, 5-hour plane ride was flown at 2 speeds. First part of the ride, the average speed was 105 miles per hour. The remainder of the trip was an average of 115 miles per hour. For how long did the plane fly at each speed?
Wow, that's a lot. What are they asking us for? What's our goal?
Find the speed.
Find the speed. Now, let's talk about physics for a second. I took physics in college. It was a lot of fun. My professor was hilarious. Now, what is another word for speed?
Miles.
Okay, miles per hour. Okay. That is called a what?
Equation.
Not really. How about when, I don't know, Mr. Lynn, do you have another word to describe? I don't want to give them the word.
Okay, so to see how fast you're going, you look at what you said.
Time.
Time, right?
Okay. But not just the time, but how quick you're going, which is the
Speed.
rate.
Rate, yes.
The rate.
Awesome.
So we're looking at this equation today.
You guys are on.
Distance equals rate times time. D equals RT. Now you have a grid already provided. This is the way we're going to solve every problem today. This will work every time. So the first thing you want to do is set up a grid.
You guys don't have to do anything, it's ready.
Okay. I already drew this one, but not for the rest of the problems today. Now, what is the total distance that this trip took?
555 miles.
500, so D stands for distance. We're going total of the distance, 555.
That's all we know.
All we know so far. How much time did the entire trip take?
5 hours.
5 hours. So that's going to go in the total of the trip.
Where of the time?
Yep, so T for time. Distance is D, R is rate, T is time. That's why I put them up here, okay? Now, do we know how far what the distance of the first part of the trip was?
5 miles.
Where'd you get that from?
Right.
That's average speed. Speed is called what?
Aaron. Wait, that's
The rate. So what was the rate for the first half of the trip? 105. What was the rate for the second half of the trip?
115.
115. Is that all we know so far? Okay. So we don't know what the first part of the trip's distance was. I'm going to call that D.
will be right there.
Yes, you should. Now, if I know that the whole distance was 555, and I know that this portion of it was called D, what's left over? How could we find out what's left over? Total what? Minus D. I have a total, and I know that the portion of the D, we don't know what it is yet, is the first part of the trip. Then I can figure out what the second part of the trip is. So my new expression for this part is 555 minus D. Now we can do the same thing for the very last column. Think about it this way. We don't know what this is, but we know that whatever it is, I'm going to take it away from here. Okay? And whatever I have left over is what goes in here. So pretend I have a cookie in the back of my hand. You don't know how much of that cookie I'm going to get to you. Okay? But whatever's left over, I'm giving to Shanika. So my whole cookie, a portion of it's going to you, and the rest of it's going to her. A portion and the rest. Make sense?
Oh, yeah, I understand.
Okay. What about the last column? We know it took 5 hours for the entire trip. Do we know how much the first part of the trip was? It could be. It could be 2.5, but do we know that? So we're going to call it,
Can't eat 2.5.
why not? I mean, we don't know what it is. We're going to find out, but we don't know yet.
Right.
Now, what's left over? I have a total of 5, and I have T of it up here. What could go here? Just like this.
5
5 minus T, very good. I'll switch colors. Alright, now we're at the part that is going to make so much sense. So, every time that you fill in the chart, when you show your work, so part 2, show work, you're going to take the first row, row 1, and row 2, and set up an equation across. What is our equation? Equals R times T. So I'm going to write D equals 105 times T. So I'm going to write it over here. One of those rolling. What is the equation I'm going to have for the first one? Very good. I'll go a little down here.
Yes, but it's down where it's a show.
Yeah, this is the show work section. What is the second row's equation? There are 2 variables in my second equation. Can I do anything with that? Well, what about my first equation? Didn't I solve for just one letter? What does it say? D is 105 times T. So wherever I see the letter D,
So they tell you T.
they tell us D. They already gave me what D is. With reference to another letter, that's handy, because I only want to use one letter, and I already have a T in here. So I want to make this a D, or a T instead of a D. So I'm going to replace the letter D in my new second equation with 105 times T. So go ahead and here. Minus, I'm going to take this equation, plug it in here. Okay, let's think back to our order, our properties of math. We have associative, like we talked about this morning, and commutative. What's another one? another property of math. We talked about commuting. We talked about grouping, who you associate with. There's another one that starts with the letter D. Distributing. Very good, Shanika. So I'm going to distribute this 115. What's 115 times negative t? Negative 115t. What's 115 times 5? What's 5 times 5?
155.
What's 5 times 5? 25. Carry the 2. What's 5 times 1? It's 5 plus 2, which is 7. And what's 5 times 1? 575. So minus 115t. Now what's always the point of solving equations? To get the... Oh, well I have a t over here and I have a t over here. How am I going to bring this t over here? Divide? That's not the way to do it. What am I going to do? Combine like terms. This is negative 105t, so how am I going to get rid of negative 105t? I'm going to add it, and what I do to one side? What's 115 plus 105? But remember, I have a negative. So it's negative 10. Now how am I going to get this 575 alone away from my t? Add it? Minus it. And what I do to one side, probably do the other. I'm going to write it up here just so y'all can see it. What's 555 minus 575? Positive or negative? Negative. What's 5 minus 5? What's 7 minus 5? What's 5 minus 5? So it's negative 20 equals negative 10t. How do I get rid of that negative 10? Divide. And now I have t equals what? Positive 2. Now, what was the question asking me? At each speed. Okay, so what's t equal? T equals 2. So now wherever I see the number 2, or t, I'm going to write 2. But what's 5 minus 2? So, when the plane was flying at 105 miles, it was for 2 hours. When the plane was flying at 115 miles, it was for 3 hours. So my entire trip was 5 hours. So did we answer our question? Yes, we did. Okay, number 2, turn your paper. You need to set up the grid just like we did for problem number 2. So go ahead and read through the problem, figure out what they're asking us for. What is the title? Is it going to be first and second? Is it going to be Bob and Jill? Is it going to be car and something? What is it? Then plug in the knowledge that you can pull from the word problem. I'll let you work on that for a few minutes. 2 minutes.
Guys are almost there.
Attention,
Okay. So have we gone through and read this new problem?
And the problem, on the page.
Number 2. What is it talking about, this new problem? I see a column already set up. Great. Good job. What are they telling us? What is this about? An executive, and what is he doing?
He's traveling.
He's driving and he's traveling. So he's driving at one point. What else is he doing? He's in a helicopter. He's flying. He lives the life. And this is always going to be the total column. Okay. What else did they tell us? The speed. Okay. All right. So what was the speed of his driving?
Average speed is 60.
For driving?
Driving is,
Okay, read it. An executive drove from home at an average speed of 30 miles per hour to an airport where a helicopter was waiting. Oh my gosh. The executive boarded the helicopter and flew to the corporate offices at an average speed of 60 miles per hour.
Sorry for the interruption, but there will be school tomorrow. It's not even snowing yet. If it does start snowing heavily during the day, we will dismiss early.
The entire distance of his trip was how many miles? 150. That's the entire distance. The entire trip took 3 hours. Find the distance from the airport to the corporate offices. Okay, what do I need to plug in now? Remember what we did for the first problem? Okay. Don't know that distance yet. What else do I need to plug in? Saniqua? What can I plug in? We don't. But we do know that the total distance is 150, and we know that this portion was D. So what is this portion? 150 subtract D. Very good, Shanika. Shanika, wake up for me, please. How many hours did he drive? How do you know that? Do we know how many hours he drove? So it's T. Very good. Now if we know the total was 3 hours, and we took away T hours, how many hours did he fly? 3 minus T. 3 minus T. So now we need to write our first equation going across the first row, which is what?
T 30 R
And what's our second equation? Now, did they already tell me what D is? 30 what? 30T. When you see the equal sign, you could say the word equals or you could say is. D is 30T. So instead of saying D, I'm going to say 30T. What do I have to do with the 60? Shanika's favorite thing. What do I have to do with the 60? Multiply what? And? Very good. So that's 180 minus 60T. How am I going to get this negative 30T over here? Add 30T to both sides. How am I going to get this positive 180 on the other side? minus it. What's 150 minus 180? Negative 30. And how do I get rid of this negative 30 times t? Add? Multiply? Divide. What do I do to one side? So t equals 1. So now what I'm going to do is everywhere I see 1, or t, I'm going to put in a 1. Now what was the question they asked us? Okay, so now we need to take t and plug it into my first equation. What's 30 times 1? 30. So this d is now, and what's 150 minus 30? 120. So how far did he drive from home to the airport? 30 miles. Boom, we're done. Okay, so for tomorrow, we will finish the problem on the back and that first worksheet we had about ratios and proportions. What I ask of you is to take your papers and put them in the pocket of your folder. Okay, we'll get you one.
Alright.
You're doing so great. What? Alright, thank you guys. And you may go in 1 minute.
Where put this stuff in?
In your folder.
There was no patching this one.
Well, I told him it was okay because he was walking in late.
That's true.